Hey everybody, Mr. Gibson here. So I wanted to record a quick video for you to kind of introduce today's assignment, and that is Explore 2 Diffusion. And so we have played around with this idea of diffusion a little bit before. I think in the STEM case you did a couple of weeks ago um, over you had a patient who had to go through dialysis, and it talked about type 2 diabetes, and a big part of dialysis is diffusion. And diffusion is really critical in some ways that your body maintains homeostasis, that internal balance, okay? So diffusion basically is just where a substance will want to move from where there's a lot of that substance to where there's not a lot of that substance. Another way to phrase that is a substance will move from high concentration, where it's highly concentrated, to low concentration. And this just happens naturally. It doesn't require energy. It happens because of all the particles of that substance bouncing into each other and then spreading out as much as they can. So think of it as like if you were to blow up a balloon and you're holding the end of the balloon closed, all the air particles you blew into the balloon are really highly concentrated inside of that balloon. If you were to open that hole, they would all rush out from high concentration to low concentration. And that's basically what diffusion is. And you're going to see that demonstrated in a simulation today in your assignment. So it says this activity allows you to further explore this idea of diffusion and how it relates to homeostasis. Okay. So first, what you're going to do is you're going to open this simulation. Okay. Once you open the simulation, it's going to show you a box, and you can add particles, you can change their size, you can change all kinds of stuff. Now, let's open up the CAMI now. It says particles move from an area of high concentration to low. That's called diffusion. We talked about that. So your investigation question today, what you're going to try and answer with this simulation, is how do temperature, numbers of particles, and particle size, and particle mass, or how much a particle weighs, affect the rate of diffusion, or how fast diffusion happens. That's what we mean when we say rate. Okay. So first, you're going to click on the plus tab, or the plus button next to the data, to show data in the simulation. You're going to add 20 blue and red particles, and check the boxes for particle flow rate and stopwatch so you can kind of see how fast it's moving. Click the green remove divider button. That's going to remove that divider on the simulation, and then you're going to see what happens to the particles. Okay, and you're going to answer that question there. And you're going to, this first step here kind of just lets you play around with it. And so you're going to do steps 1 through 10, okay? And then you're going to repeat steps 8 through 10 3 times, okay? And you're going to record the average rate of diffusion here. Average is simply where you add up the totals and then divide by how many there are. So you're doing it 3 times. You're going to add up the rate for the 3 trials and then divide it by 3. Okay, if you have any questions about that, just email me. Okay, then in test 2, we're really going to get into the nitty-gritty of diffusion and talk about how temperature may affect the rate of diffusion. If it's hot, does diffusion happen faster or slower? If it's cold, does diffusion happen faster or slower? You're going to figure that out today. And they're going to see how all of these factors affect the rate of diffusion for test 3. Okay, and then in this data table, you are going to run a control group, test the increase in temperature, test a decrease in temperature, and then on the third test, you can pick whatever variable you want. You can make it particle size, particle mass. That's really there for you to play around and kind of design your own experiment for test 3. Okay, and then you're simply going to answer these questions in the conclusion. Okay. Talk about the terms equilibrium and diffusion. How are those related? Okay. And really, it's okay if you're not 100% right on these. I don't really want you necessarily Googling these, because I want to know what you think based on your experience with the simulation. Okay. And you're simply going to create text boxes and type them here. This is an explore activity. So if these aren't, 100%, scientifically, ready for an essay, ready to publish in a scientific paper. That's okay. Okay, this is merely you're learning through this as a process. And so your step in this process, you may not completely 100% understand everything, and that's okay, because hopefully you'll understand just a little bit more after this activity. All right, if you guys need any help with this, feel free to email me or call me between 9 and 3 on the school phone. I look forward to seeing how you guys do on the assignment. All right, good luck, guys.